So what happens when you smash a 100-year-old industry, one built on steel and steam, into the most advanced tech on the planet? Well, today we're diving into that exact collision. We're looking at the incredible shift in the energy world, a journey from crude oil to pure code. How is AI completely rewriting the rules for one of the world's most critical industries? Let's get into it.
For over a century, the energy industry ran on crude. It was a world of physical gears, mechanical parts, and, reacting to problems. If something broke, you'd go out and you'd fix it. Simple. But code is flipping the script on everything. We're moving from a world that's just reacting to what already happened to one that can actually predict and shape what's going to happen. It's a total reinvention.
Our source material for this really hits the nail on the head. This quote here says it all. It's about bridging two worlds that just don't speak the same language. On one side, you've got engineers who live and breathe the physical reality of a refinery, and on the other, you've got data scientists who live in a world of algorithms. So our goal today is to build that bridge for you. Okay, so where did this whole revolution even start? It wasn't with some super smart AI, not at first. It began with something way more fundamental. See, before you can give something a brain, you first need to give it a nervous system. The industry had to learn how to feel, how to gather just massive amounts of data from every single pump, every valve, every pipeline across its huge operations.
And this nervous system, it wasn't built overnight. This story literally spans decades. Way back in the 1930s, control was all physical. Think hissing, air-powered lines moving gauges around. Then, fast forward to the 70s, the first digital controller showed up, which was a huge leap. The 90s were really pivotal. We started not just collecting data, but actually analyzing it. And then, in the mid-2000s, the Industrial Internet of Things, or IoT, connected everything, creating the absolute fire hose of data that modern AI needs to drink from.
So, with that nervous system in place, capable of feeling every tiny vibration and temperature change, the stage was set. It was finally time to introduce the brain, an AI specifically built to bring real intelligence to all that industrial muscle.
And that brings us to this really key idea from our source material, Applied Engineering Intelligence, or AEI. Now, this is not the kind of AI that writes poetry or makes funny pictures. No way. This is an AI that basically thinks like an engineer. It's grounded in the laws of physics, it gets thermodynamics, it knows that any recommendation it makes has to be not just smart, but physically possible, and, above all, safe.
So what does that actually look like in the real world? Let's take a really high-stakes situation. Imagine a critical pump on a remote oil rig hundreds of miles out at sea. If that one pump fails, it could cost millions. So how on earth do you prevent that from happening?
The answer is you predict the future. The AEI is constantly watching all the sensor data, tiny changes in vibration or temperature, stuff a human would totally miss. It spots those faint signals that scream failure is coming. It calculates exactly how much time is left, what they call its remaining useful life, and then it schedules maintenance just in time. It's a complete shift from fix it when it breaks to fix it before it even thinks about breaking.
And this predictive power isn't just for one machine. It scales up to optimize an entire refinery. For example, AI can perfect the blend of crude oil coming in to get more valuable products out of cheaper stock. It can manage the catalysts in cracking units to squeeze out more gasoline. And, get this, it can intelligently manage energy use, cutting costs and CO2 emissions at the same time. It's a whole suite of smart tools, all working in concert.
But look, predicting failures, that's just the beginning. The true endgame here isn't just an AI that advises you on what to do, it's an AI that actually does it. The future is autonomous, and honestly, it's a lot closer than you might think.
Let's kick this section off with a question that, it sounds like science fiction, but it's quickly becoming an engineering reality. What if an entire refinery, the city of pipes and reactors, could literally run itself?
The key to pulling that off is a concept called multi-agent systems. And it's wild. Just imagine a digital society living inside the plant. Every single piece of equipment, from a small pump to a giant reactor, becomes its own intelligent agent with its own goals. These agents then talk to each other. They negotiate in real time. They barter for resources like energy or raw materials, all to make the whole system run better. What you end up with is a resilient, self-organizing operation that can adapt to almost anything. And the absolute final frontier for AI and energy? It's got to be research, and it's powered by quantum computing.
For years, we've used computers to simulate new materials, but those were always just really, really good approximations of reality. Quantum simulation is a whole different ballgame. It lets us model how molecules interact with near-perfect accuracy. That means we can invent brand new, revolutionary catalysts and materials entirely inside a computer, which just supercharges the speed of innovation.
So when you put it all together, where does this all lead? Well, the ultimate vision is pretty profound. It suggests that the next industrial revolution won't be about getting more efficient at exploiting the planet's resources. Instead, it'll be about using this incredible intelligence to co-create a sustainable future with the planet. It's a shift from just taking to collaborating, and that is a powerful idea to think about.